Hello, everybody. So tonight's probably going to be a fairly short night, hopefully not too long. The notes are only like that. List of things to do is only half a page, but a couple points to cover still. One thing that I wanted to start with, I guess it was kind of implied the other day, but when I went back and reviewed it, I always like to think back over after the lectures and think of things that could have been said better or whatever. One point that I thought I probably should have explicitly stated, it was kind of implied, those languages, like we were looking at, programming languages, that is a piece of software that has to be installed on a computer. Like I was doing them here on my computer, and I already have those languages installed, so the things were just running. But if you maybe tried to follow along and do that, it might not have been installed. So yeah, we talked about it a little. The computer itself is running machine language, a bunch of ones and zeros. I'm just making one up here. The computer knows that, and that's really, really hard to work in. For one, we don't read it right to left when we work that way, but that's something different. That's really, really hard to work in. So we need a piece of software in the middle. And that's what those programming languages really are. So for example, on my computer, I already have a piece of software called Java installed. It's actually a Java virtual machine. So with Java, there's a fake machine running on the computer that actually runs the code. And I have a piece of software on my machine installed called Python. So, and that software recognizes things that are more meaningful to me. So then I can put things like the word print, and I type that in a text file, and then both of those pieces of software know what the word print means and turns it into something the computer knows. I just wanted to take a moment and state that explicitly, since it didn't get stated directly the other day, and I wanted to make sure you knew that. So for like those that we were looking at the other day, and I'm going to show you another alternative here in a few moments. Maybe that's why it didn't make the notes to directly talk about that, because I was going to show you a better alternative, and then, well, Tuesday night ended up taking longer than I'd anticipated. But to install those, you would just search for the language. So you would search for like, normally I would put in numbers. I'm just going to put Python programming language. Is a good starting point. And there's this site, welcome to python.org. If we go to this site, there should be a button that says download, like you're probably familiar with from most every piece of software. I guess one of the biggest differences, and the point I wanted to get to that we didn't get to the other day, is there's not a user interface on this language. The language is software that all runs in the background, and then we put together text files, and then it makes sense of those text files. Yeah, then you just go to downloads for whichever one. So the latest version is Python 3.9.6. And like any other piece of software that you wanted to install, you just click you just download it, and you'll get this exe installer. Usually it gives an MSI installer. Those are the ones that the Microsoft installers are the ones that just run straight through. And the .exe installers, the executable installers, those are the ones with the wizards where we have to keep hitting the next button. But yeah, a programming language is just like any other piece of software. We'll just kind of install it on the computer, and then we can start writing up instructions that mean something to that programming language. I just wanted to start by stating that explicitly, because when I reviewed the video of the lecture the other day, I kind of felt like, well, since this is just very the very basic introduction to that, I probably should have stated that explicitly. So, to work with programming languages, we do have to install software, but there are alternatives. So we'll take a look at some of those. Another thing I had on the list, the AWS servers, they did approve the account. So we all have, so there's a AWS account with $50 worth of credits for us to basically play around with. And that's something that I can say with fair certainty that you will see in some of your classes. And as far as cloud computing in general, just in the world, Amazon Web Services is over a third of the cloud and growing. So if you're going in IT, you will definitely see AWS stuff. So I wanted to take a look at that in this class. And I got the email just a couple hours ago, so it's active now. So we'll look at that next week, kind of just a quick introduction on how to set up the server, because when the AWS accounts, it's not like a hosted site if you've ever done any of that stuff where things are ready to go and you just kind of do it. AWS is a blank server, so you have to set the server up and everything. So I kind of wanted to walk through the steps of doing that in class, because it is something you will definitely see. And that way, when you encounter it in other classes or just in our modern world, you'll have some sort of idea in the back of your mind on what to do with it. There are two pieces of software that we'll need. Well, actually, there's one piece of software we'll need in order to access it, because it's a blank server, so we have to access it through some sort of protocol. We'll use secure shell protocol. We'll do this next week. So we'll need a piece of software to access it. There's stuff built into the computer, but that can be a little tricky to set up. So we'll just use some that's set up and easy to use. But that is a big text-based thing, and there's a lot of instructions, makes it hard to memorize. So I was also going to send out a link for this software called FileZilla, which has a nice graphical user interface, and we'll see folders and files. It's like split in half, so we'll see the folders and files on our machine and the server, and then we can just drag them back and forth. It's much easier to transfer files that way. It's a file transfer protocol stuff. But that's for next week. I just wanted to let you know that the AWS stuff is active, so we'll take a look at that either next Tuesday or Thursday, probably Tuesday, and then we'll talk about the security stuff on Thursday. So that's coming up. But this week we're still looking at some software development things. The other day we looked at a couple quick examples. I just typed up some stuff here on my machine and talked about interpreted versus compiled languages, and we just printed some words to the screen, nothing too fancy, but it's feeding instructions into the computer. That's basically what software development is setting up the instructions, and I really enjoy it. I feel like it's, at least in my mind, I categorize it with art stuff. I get the same feeling I do after writing a song or painting a picture or something creative. It's that creative aspect. And the medium is kind of data. We're manipulating data to create something. But I really enjoy it. I know everybody's a little bit different. There were still just a few more things I wanted to look at with that. In particular, you will have there are two assignments this week. Those, I think they're labeled foundational skills. One of them is to write a small program in Python, and there's step-by-step instructions on that. We'll look at that here in a moment. But the other one is another type of programming that we didn't quite get to the other day, and that is, I'll say coding. There's two types of things. These are more sort of loose loose usage terms. I guess there's technical definitions for them, but this is more how we use the words. We have programming, which is what we looked at the other day, the declarative, and in particular the imperative languages. I'm going to say step-by-step instructions, just to summarize that stuff from the other day. Like if we wanted to add two numbers, create a spot to store something and put a number in there, create another spot to store something and put a number in there, create another spot to store something and then add those two numbers. So step-by-step instructions, how we do something. But another thing we do quite a bit, I mentioned that software is manipulating data. And if we intermingle our data into those step-by-step instructions, it can really start to clutter things up. So it's very common to treat our data separately. And that's what we usually, at least generically, refer to as coding. To summarize this, I'm just going to put prepare the data for usage. So like the examples this week, programming, feeding in those step-by-step instructions, the assignment is to do some of that in Python. The most popular programming language in the world. We talked about that the other day. Everything in Python is set up to make it easier for the programmer. Makes it run a little bit slower, but machines consistently get faster and faster and faster. So over the decades since making everything easier was created, we've cared less and less and less about that slower part because the machine gets faster and faster. The machines are getting faster and faster and faster. So until we get up to like really huge programs with it's not noticeable on human time scales, the faster. And it's differences between nanoseconds and milliseconds. It has to do a whole lot of things before a human will notice that difference. But it is, whenever it does get large, we start to notice the difference quickly. But we usually go with the easiest one, by far the most popular programming language in the world, because everything about it makes the language easier to program. Whereas coding, it's like we're preparing our data for usage in a program. The example we're going to use in the homework this week is HTML, Hypertext Markup Language. You may have heard of that. That's the standard for encoding web data, websites, web pages, all of that. Yeah.
I'm sorry, can you say the long name for that again?
Hypertext Markup Language. I'll write it down.
Thank you.
Can you see that?
Yeah, thanks.
Okay, so we talked a little bit about Python the other day, and we're going to look at it again here in a moment. Not on my machine because of that stuff we started talking about, but probably where you'll write it down this week. So I'm going to write some stuff over here. So the last part of that name, I guess it's useful to have wrote that out, markup language. This is just one of many types of markup languages. And I'm originally familiar with markup languages because I started using computers back in the 1980s. So it was probably way before any of y'all's time, but in history books or something, you might have heard about dot matrix printers. They were kind of like typewriters. They had the whole ribbon like typewriters, and then there was this little, the paper would be back here, and there's a little head that just punched a dot. So there would be a ribbon of ink, and it would just punch a dot, and if it wanted to print an A, it would just put mark a bunch of dots on there to make it look like an A. And back in the mid 1980s, when I was starting to use computers, those had gotten nicer and nicer and nicer. And screens kind of did the same thing. I know you've seen pictures of the old screens, like those old green screen, black and green screens on the Apple IIs, where we would turn, if we wanted to write the letter A, I guess I could have left that same picture up there. We would turn pixel by pixel on until just the pixels that looked like an A were on. Similar to the printers, but the printers advanced quicker, and we hit a point where the printers could do more than the screens. So if we wanted to like print out a text file, for a simplest example, I'll write up those words. We might have that standard example we were looking at the other day. I hear thunder, so looks like there's a pop-up shower coming. If the video suddenly cuts out, I'll grab my phone and be back on in a couple seconds time. It's the season for pop-up showers. So we were looking at that simplest example the other day. Say I want to print these words on a piece of paper. This is back in, I don't know, around 1987, 88. I started using that. And the computer would show those words. The dot matrix printer would print them out to look about the same, but the printer could do more. So maybe I wanted to make the word hello bold. The printer had no trouble doing that. Because the printer could just keep hitting that dot in the same spot and just let the ink run over. But the screen, like on an old Apple II screen from the mid 1980s, couldn't show that bold text. So we needed something else to tell the printer that we wanted it bold. We needed to pass that information in. We needed to code that text. So not necessarily programmable instructions to be carried out, but some sort of coding on that text to say it was bold. And we would use markup languages. So instead of the word hello, we would wrap it in these tags. This isn't the one from back then. I'll just do this. And then these extra little marks here would indicate to the printer that this word was supposed to be bold. Start making things bold here and stop making things bold here. And that's a markup language. We use these tags to define our type of data. So tags define type of data. And it adds a little bit of extra typing for the human, but there's a trade-off. So I'm going to write an example here. Yeah, I'll just put the word tag. So we have this starting tag, and then whatever our data is, data itself, and then the ending tag, which we mark out our tags with these little angle brackets and give it a name. So that tells what type of data it is. And it's a little beyond the scope of what we're covering here, but we can put other metadata inside of that tag, other information. We call them attributes. Like in that case of the old printers, like I was talking about a moment ago, we might put an attribute in there to make that bold or make that red as well as bold and other information. But the main thing is our data, it got a little bit longer, but that part that got a little bit longer tells us what type it is, what type of data we have. It clearly marks the starting point of that data, and it clearly marks the ending point of that data. And y'all are just getting started into the IT field, but so I guess you might have to take my word for it, but that is the perfect thing for a CPU because of the way that all those ones and zeros interact. When that gets translated into machine language, our data, including its start point and end point, is the perfect way to pass it through a CPU. So it's just a little bit extra text for, from a human perspective, and typing's easy, right? Most of us type many words a minute because we're quite used to keyboards. So adding a couple extra symbols in there is no problem. And it makes it sort of the ideal thing for a CPU to process that data. So it's a really nice way to prepare our data for usage in other programs. The one we're going to look at, the example in your homework that you'll look at is HTML, which is very common because that's the standard of how we do it on things across the internet. We also often use XML for just transferring data between programs, and there are several other ones, or we can create custom ones if we want. It doesn't necessarily have to fit one of the standards. They're really easy because, you know, all it is we just tell the computer that if it sees a certain tag, what to do when it sees it. So it's not hard to create them, definitely beyond the scope of this course. But it makes for the ideal way to process the data. So it's a standard way to prepare data to be transferred across the internet. So when we want words to show on a web page, that's kind of what we put them together that using tags. Is that everything I wanted to say about those? Yeah, just kind of a rough introduction at this level. You'll kind of do it. I believe most of y'all have to take the class on HTML and CSS because that's so prevalent in our world. It seems safe to assume that anybody that's going into IT needs to know how web pages go together. So it's required for most people, I believe. You'll see more details there, but it's fairly straightforward to work with. I'm going to go ahead and share my screen and do a simple example of HTML stuff. So I'm going to hit Windows E to open the File Explorer, and I'll go to my working folder. So Alt D to get to the address bar, then Documents, delete folders where I do all the work. So there's that stuff from the other day. We went through and did the instruction stuff on how to print the words "Hello World" to the screen in both the Java programming language and the Python programming language. And then talked a little about batch files, where we just take our command prompt instructions and save a bunch of them in a text file. That is still my recommendation if you have time to practice stuff, to practice working with batch files, because no matter where you're heading in IT, that will be useful to just compile a set of instructions that you can run over and over and over again. So for like hardware people, you're going to run the same diagnostics on a machine over and over and over again. So instead of manually typing those steps instructions into the command prompt, just save them all in a text file and then keep track of where that script fails on a particular machine, and you have a very quick way to troubleshoot the broken component. Or for security people, to trace things through and do like some computer forensics and track down security breaches. You're going to probably follow a similar pattern every time of things you're checking to see what happened and when it happened. You can just save all those instructions And in the case of security people, it's more because it's just faster, right? If all those instructions are already typed up, that program is going to run a whole lot faster than if you had to type them in one by one. So a very useful thing you might want to dedicate some practice to. But now we're moving on talking about markup languages and coding our data instead of, and that subtle difference that's more of a usage thing. When we say programming, we're talking about how do we carry out those instructions? What instruction needs carried out? Do this, do that, and the step-by-step instructions. That's what we usually mean when we say programming. But we also have coding, like HTML. So I'm going to open a new thing here. I'll go up to the address bar and start Notepad++. That's just one text editor. I'm going to show you here in a few minutes. We're going to look at a better place to program all these languages we've looked at and more. So just to start with the example, I'm going to use just a simple text editor. And I need a new one. Well, I'll follow the same pattern. I'll call it, make a file called say hi and .html. And so I mentioned that this is what we use. Yes, great. This is the standard we use for web pages, which means we're going to look at it in a browser. So the browser already has the step-by-step instructions on what to do with the data we encode into HTML format. So I'll start with, we just want to say, put the words hello world on a web page. I'm going to come down a couple of lines and I'm just going to type the words hello world just to show you what happens. I think that's how I was typing it the other day, a couple exclamation marks. So just some text in there. So if I come back over here, you'll notice that it used the icon for the browser. I have Google Chrome as the default browser, but whatever your default browser is, most people probably see Edge there. Every Microsoft update, it seems to try to change your default browser to use Edge instead. But if I just double click on that to run with it, because the computer knows that's something that should open with the browser, it'll take a second. Oh, those words showed up. So that worked to get the words right over to the screen. That's all we need to, right? So in order to get words onto a web page, the instructions on how to do that are already put into the browser. So all we need to do is tell it what data to put there. I sent this text. If I look at a couple things, if I right click and come down to view page source.
So did you, I'm sorry, did you just make your own web page? Is that what you did?
Yeah, you can see here in the address bar, it's just telling that. Not a very good one. That was the next point I was going to make, is because I don't have any control over that. It will display the text, so we can see that, and that's the assignment for this week, Matthew. It's to make a simple web page. There's step-by-step instructions. I just wanted to talk about it a little so that you kind of know what's going on when you follow those step-by-step instructions. Another thing we can do is in any of our browsers, if you hit the F12 button, which you wouldn't be able to see. So the same thing, if I right click and come down to this button that says inspect, it'll open this panel over here that shows us what's going on. So it says notice there's some of those tags I was talking about. There's a tag that a start HTML and an end HTML. It also added these other tags in. I didn't type these tags, the browser just needs them. So that's one thing we always want to type, well, those tags. At the bare minimum, we need to type the ones that it added in to give us a little bit of control over what that data does. So the HTML starts here, then all the data we pass into it, and then the slash means end. So everything in between that tag, this opening tag, and this that we call a closing tag is our HTML code. And well, it added in this section called head, and that's for background data, like other files we want to connect to, style sheets and scripts and things like that. Stuff to tell a search engine about the page, because a search engine has those little bots doing everything automatically. It doesn't need the fancy formatting like we make for humans. So we can condense it and put stuff there. So background information goes in this, we call it an element. The section from an opening tag to a closing tag, we call that an element. And we'll put background information in there. And then the body. Notice it added in opening body tag, and a closing body tag has that slash on it. And through those words in between there. And over here, there's a lot of extra stuff involved. If I click on it, notice down here at the bottom of the screen, it tried to show some stuff. These are style rules. So this is how it's going to display. And there's not anything that it can really display about it. So whenever we make an HTML file, so to answer your question from a moment ago, I kind of made a web page, but it's not in the right format yet. I put some text that would show on it, but we need to encode it into the format of a web page. So the first thing we always want to do is add in those, go ahead and type those tags that the computer automatically added in. Because
so you're saying you can see it, but we just can't interact with it?
Yeah, there's no control over it. We can see it, but it's going to print out like this. Oh, kind of like I was talking about a moment ago with the back in the 80s, where printers could do more than screens. We have the information like it's showing on the screen, but we don't have any way to access this piece of data. The computer can't hone in on those words that I typed there. It can't identify them to change the color of them or make them bigger or smaller or anything like that. So that's where our tags come in. It identifies the type of data we have. And the computer tried to add in a couple. So right off the bat, we always want to add those in. So in angle brackets are greater than, less than symbol from math class. We put the type of data we have. So everything here is HTML data. Then I'll come down to the bottom and I'll put /HTML. Notice how when I click on one of them, it connects to that other one. Or I have the little expansion thing. It knows where that data starts and where it's, well, in this case, all we have is HTML data. So it knows where the HTML data starts and where it stops and connects it all as one thing. And then those other two that it automatically added in for us, the head, then end the head section. I won't really get into that. And then there was a body section and an end of the body section. And what I just did there, there's a subtle point there that if you're doing programming, will make a world of difference. We're used to English, right? It might not be everybody's first language, but I have spoken with all of you. Also, I know you know English. I'll use that as an example. So in English, we read from top to bottom, left to right. We go to the first line and read that, starting on the left side and going across. Then we go down to the next line. But our programming languages, even though we reorganize stuff so that they do that in general, there's still some wiggle room there. I guess you can say it that way. So working left to right, top to bottom is not the best form to put your program in together in. So like you notice when I did those tags, whenever I put a tag, this is a good example of that. This opening body tag's up here and the closing body tag's way down here. But the first thing I do is when I write that opening body tag, I skip down a few lines and do the closing tag, and then come back and do what's in the middle. So working with programming and encoding, jumping around makes a world of difference. Jump around in the order that your brain thinks about it in, and it just has to be in a certain format at the end for the computer. That's a subtle point, but if you start doing a lot of programming, you'll quickly see the advantage of that. It's just jump around and put it together in the order you think about it in, and don't try to put it together in the order the computer needs it in, because we don't think the same way that computers process. So we have to adjust to that stuff. So this is still going to look exactly the same. If I saved it, if I come over here and reload it, still looks exactly the same. Those words are showing there, but I still don't have any way to access that data. It's just those, we can keep adding tags and access that data more directly. So our most basic type of data is paragraph data. It's in the name of this thing, hypertext markup language. So it is designed to work with text. So that's what it's going. Our most basic type of text is a paragraph, which this was created back in the 80s, late 80s, early 90s, when memory was a very, very precious thing, and we didn't want to waste it on computer experts. So all the original tags are abbreviated. So a paragraph tag is just abbreviated with a P. And then I'll come over and put the ending tag, which they'll look the same, and then the difference is that little slash. Actually, I'm gonna put a line break in here just to express that point I pointed out a minute ago. Notice now, from our starting tag to our ending tag, it knows those are connected and have a collapse and expand thing. So I could either look at that or not, but that's the advantage of markup languages, is every piece of data includes where it starts and where it ends, which is sort of a perfect thing to run through a CPU. Now if I reload this, not really much change, but you'll notice over here in the inspector panel that I opened up, we have those tags now. And now when I click on that, down here we can see that there's already some style rules applied to it. So now we can access that data and do things with it, like apply style rules. Notice down here, it kind of set the style rule up like this. A P, that's the name of the tag I gave it. And then a curly brace, opening curly brace and a closing curly brace. And then in between each one, there's like some sort of, there's two, each line is split up into two different parts. There's this first word, which it shows in red, and that's a property of it, some sort of property of it. So like, how is this going to display? It's going to display in block format. It's going to stick things in blocks, and block, a block takes up the whole screen. However, you can see it stretches all the way across. And if I had another paragraph, it would be right underneath that, stretch all the way across. And we can access our data and change the way it appears by manually typing this stuff. So I come over here, and that is data about the web page. So that goes up here in the head section. So here in the head section, I'm going to add another tag in that says style. Oops. And then in between it, I'm going to basically put this thing. Well, actually, I'll just copy this. I'll grab it from there where the browser tried to preview it for us and paste it in. So all that's the default stuff there. So that's going to happen no matter what. Well, I'll change some stuff about it. And that way you can see like accessing and controlling that. So display block. I guess one thing I could set it is display none, which y'all can probably predict what that's going to do. So now if I pull it up, we can see it's still in the code, but we can't see it because we set the display to, well, we set it to not display. I think it was set to block start. So there's different ways we can measure things. You'll notice down here, we have the next four things are about margins. That's the space around our paragraph. Then we have padding, which is the white space inside of our paragraph. So the space around it, they said 1 EM and 0 PX. So you're probably a little more familiar with what PX would be, right? That's saying 0 pixels. But this EM, that seems a weird thing, right? What that is, it's a traditional printing measurement. So EM is one of the measurements that goes all the way back to Gutenberg, the original press there in Gutenberg, Germany. And EM is the largest letter. So 1 EM wide is usually an M or a W, because that's going to be our widest letter. So the width of a M, so this is saying make it the width of one widest letter. We'll probably add some more in there. Let's just say 13. So then it's going to start 13 letters. Oh, it should. So looks like that was above it. So instead of, I was talking about width, but the letters also have a height, right? So changing that line, block start, but 13, it's going to have the space of 13 letters above it. Let's change that back to 1 and try changing this one. This is how we learn this stuff, right? Just make a change and see what happens. Reload that. Well, it looks the same, but over here we can see a difference when I hover over it. I said the margins are the space around it, which is kind of highlighted in the tan or brown, maybe orange, whatever color that is. And we can see there's a whole lot of white space below it. So that's that line end. If I added some more stuff underneath this, more words. I'll just stick some more words down there. There we go. That took forever to reload. You can see it, that line end added a bunch of white space afterwards. I'm gonna take those more words out. Take that out. This is not what that did. So let's see what these other ones do. Inline start. I have a pretty good guess because we saw that those first two were the space above it and the space below it. So I'm guessing inline start is the space to the left of it, right? Does that seem a reasonable guess to everybody? So if I add a 13 there instead of a 0, and save it and reload it, yep, you can see it moved over, but only 13 pixels that time. So we have those different measurements. It started 13 pixels over. We could change it and use that EM again, 13 characters. That's a very nice one, because if we use the EM to size things, we're doing the sizing based on the data we put on the page. It's not arbitrary measure. It's not standard measurements like a pixel, which a programmer pixel does not match a screen pixel. I mentioned those old screens earlier, the dot by dot screens, like those old black and green Apple II screens y'all have probably seen in history books. Back then, a programmer's pixel and a screen pixel was the same thing, but they are not the same thing anymore, but it is still a standard measurement. Or a traditional printing measurement is points. I assume everybody's probably encountered that in your English class, right? Because English class always refers to this, the style rules all say things in points. And a point is 1/72nd of an inch. There's 72 points in an inch. So it's a very standard measurement. It's going to be the same, it's that same size, whether I do a 12-point font. You notice it didn't change. I started with what it already was because I knew what it was. But whether I do a 12-point font or a 42-point font, you can see this space over here doesn't change. It's a standard measurement. Whereas if we used EMs, I'll go back to 12-point font. If we used EMs, that one changes because that's the size of our letters. There are actually several of them. There are a lot of measurements. We use percentages and everything. You can see now it's way over there. So I said start 13 characters over. And if the font size changes to maybe a 22, I'll just switch 12-point to 22-point, but we're still measuring things based off the data we put on the page, the size of the letters we're writing on the page. And see, it moved over again because 13 characters at 22-point font is obviously a lot bigger than 13 characters at 12-point font. But that is probably a good starting point, right? Just play around with things. If you open the inspector, which in all of your browsers, you can push the F12 button and F12 will open that. But for the example here, you can't really see what we push the button. So you can also right click in white space. Make sure you right click in white space because if you right click on things, sometimes stuff will happen. But if you right click in white space, you can go to inspect and kind of see what's on that page and just copy and paste those things as style rules it shows as a starting point. Change them around, see what happens. That's kind of how we learn to program. There are some other things. Change the color of it. So I pointed out the name. I pointed out it a couple of times, hypertext. So everything about HTML is trying to do stuff with text. That's what it defaults to. So if we just say color, that's how we change the color of the text. And we have a long list of them. Let's say green and get a green text. But instead of words, one thing about the words is if we use the names of the colors, they will look slightly different on different machines, depending on, there's a lot of factors involved there. So a better way to do colors is just directly type in the numbers. So usually when we do colors, we enter it in hexadecimal values. I mentioned those the other day. So let me just put a quick review on the board. So say we have some binary data. 1 0 0 1 0 1 0 1. What is that? That's 128 and 16. What is that? 128 plus 16 is 144. 48, 49. I think that's 149. But whatever it is, 1 byte of data, 8 bits. And for humans, working with all those ones and zeros is kind of hard to work with, right? The other day I pointed out, was talking about it, we just need more symbols. I mentioned the base 60 encoding, or base 60 numbers. You've probably heard of those from the system used in Babylon. We still use it on clocks, but we use those little, each section of our fingers, then we can count to 12 5 times, or count to 5 12 times, like on a clock. But humans can easily deal with 60 things, right? We can count that on our fingers. So we need more than 2 symbols. Our normal numbers that we use here in America is base 10. Again, because we have 10 fingers, so it makes it really easy to count on our fingers. But we need more than 2 symbols. So one way we get around that is we work with our symbols 4 bits at a time. So instead of working with all those ones and zeros, we'll work with them 4 bits at a time. So then where we have 8 and 1 is 9 and 5. And then we just take the numerical representation of that, those 4 bits, and it gives us a way to work with binary without such small numbers. And that's hexadecimal, which is base 16, which everybody is required to take the class where you will learn that in a lot more detail. For the point where what we're looking at right now, it's numbers, and we're counting up to 16 instead of counting to 10, which is kind of a problem because, well, here in America, we base it on 10, so we only have 10 symbols for numbers, which means we need 5 more symbols. We can only go from 0 to 9. So we need a few more. Actually, we need 6 more symbols. We only have 10. We have 10 and we need 16. And we don't want to use things like 1, 3. We don't want to use 2 symbols to represent one thing. So what we do is just use the first 6 letters of the alphabet, A through F. So 0 through 9 are the numbers 0 through 9 like we're used to. And then 10 is an A, and 11 is a B, 12 we represent with a C, and we can do it counted on one hand. So like A is 10, and then you can just count the rest of them. So like B, C, D, E, F, and count out the rest of the symbols. But we want to, it'd be nice, getting back to the point I was making a moment ago, why I drifted off into that little sidestep there, is the most consistent way we can put colors is if we directly type in the binary code for a color, which would be why I talked about that, right? It's hard for humans to work with ones and zeros, so we work with them 4 at a time and type things in hexadecimal. So to do that, we start with the hash key, the pound sign. There's lots of names for that symbol. The thing above number 3 on the keyboard, whatever you want to call that symbol. Lots of names for it. But we start with that to say we're going to enter a hexadecimal color. And then we give 2 hex digits for a red amount of red in it, 2 hex digits for the amount of green in it, and 2 hex digits for the amount of blue in it. So maybe I'll do a lot of red. So A2, maybe just a little bit of green, 0, 7, so barely any green, and I don't know, middle in the 8, 1 for the blue. So some red, green, and blue mixed together to get any of our colors. Gives us kind of a purpley color. And then we can change that. So maybe just a little bit of red. So I'll go with like 23 on red, a very small number of red. E2, so a bunch of green, and CC, a whole bunch of blue. And mix the red, green, and blue together. And get this sort of a cyan looking color. So that's how we set the colors. Background color. And well, if we say color, we're talking about the text. You might want to change the background for it. And we can do that the same way. Enter a hex value. Just remember, each hex symbol is 4 bits. So we start with that hashtag and then give it 2 hex symbols for an amount of red. So maybe, I don't know, A7 Then just a little bit, I'll do a little bit of green, 3, 4, and a bunch of blue again, 9, 8. I'm just picking those randomly, but so that's 8 bits for how much red to put in there, 8 bits for how much green to put in there, and 8 bits for how much blue to put in there. And that gets our background color. And you can see we can start, those tags give us a way to access that data in particular. We're able to move it around to a certain spot on the page. And we did so by telling the computer we wanted to do stuff with that P tag, which stands for paragraph. And then we just adjusted these rules, kind of copied and pasted what the browser put there by default, and just tried to make some changes on them, see what happened. The colors are something different, so you'll want to play around with colors and find nice sets of colors. One other thing about colors. Most people are probably familiar with the elementary art class, right? Where, is it okay if I erase the board? This stuff's been up here for a moment, so hopefully it's in your notes.
Yeah, you can.
Okay. Most of you probably learned at a young age that we get colors by mixing red, blue, and yellow, right? I just said we mix red, green, and blue, which seems contradictory, but it's actually 2 types of colors. So I'll draw a little light bulb up here for a source light. There's 2 ways that we can see colors. Nope. That's supposed to be a piece of paper. I'll draw a smiley face on there and try to color it yellow. There we go. That'll work. So like a yellow smiley face on a piece of paper. That paper doesn't emit any light, right? If we turn off the lights, we can't see that paper at all. And so in that case, what we really see is the reflected light. Comes back over here and hits the light, goes from the source, reflects off the paper, and our stick man can see it. And for reflected light, it's a red, yellow, blue mix in order to form the rest of our colors. But that's not the only way, that's not the only path this light could take to get to the stick man's eye, right? We could also have the source light directly. And for source light, we mix red, green, and blue. So that's why it might seem different than what you learned in art class, because obviously in art class, you're putting colors on a piece of paper, so you want the reflected light. And actually, that's not even red, yellow, and blue. It's magenta, yellow, and cyan. Just those are kind of big words to teach to 5 or 6 year olds, whatever age it is when we first learned that. So we say red, yellow, and blue, but it's a mix of magenta, yellow, and cyan to give us reflected light, and a mix of red, green, and blue to see source light. And obviously the screen is a source light, so we need to do the red, green, and blue mix to get that. So I guess the question is, where do we type all this stuff up? I share my screen. The other day, I did all this I typed all these things up in Notepad++, just making examples. So it's going slow. Yeah, I just opened this text editor here on my computer, typed in the text. Like I started with 9th, and what I probably should have explicitly stated the other day is the Java programming language, and the Python programming language. Those are pieces of software I have already installed on my computer. So my computer knows what to do on. The batch file, well, like this, when I type in these words, the Java programming language is installed. So the computer knew to use those words to generate this bytecode file that we looked at the other day. Or the Python programming language is installed, so the computer knew to look at the Python language line by line because it's interpreted. Look at line 1, run that instruction, which is not one here, same thing 2. We finally get down to line 3, translate line 3 into machine or assembly language and run that instruction. The computer knew what to do with it. And then the batch file, well, that's command prompt instructions. So obviously the Windows computer already knows what to do with Windows command prompt instructions. The HTML was a little bit different. I typed it up here in this text editor and opened it with a browser. But it'd be nice to have a place where we could type all this code at once, right? And that we generally write and run and test our code in what's called an IDE. So I did that backwards. I think I'm supposed to write the words first and then put the anagram. But that stands for Integrated Development Environment. Which is quite a mouthful for saying a place to write code. So we just call it an IDE, an Integrated Development Environment. And there are lots and lots of them. Like all software, there are lots of alternatives. So I'm going to point you towards one that I've been using for a couple of years now that is I find incredibly useful. It's probably the most useful. There's some you can install. There's a lot you'll come across. Some of you all may have encountered Visual Studio before. That's a very popular one. I guess the thought it's along the same lines of, sorry, I couldn't see. Those light leaned like straight out my window and I couldn't see the screen for a second there. When we looked at documents and then against spreadsheets, I pointed out that I'm a Google Docs user because of the advantages of the cloud. And I know of a nice IDE on the cloud where we can type programming languages with all those advantages of working on the cloud. So one I found a couple years ago is repl.it, which is actually an old address. This forwards to something else. We saw that in our network section, right? When we did the NS lookup and it kept correcting the name that we typed in for ivylearn.ivytech.edu. Those are just masked human readable things. And eventually there's an IT address in there somewhere, but this is the old address, but it forwards to the new address. And I can't recall what the new address is. I think it's that with a .com at the end. It seems to be going very, very slow. Why is that not going to the page? Uh-oh, I didn't lose connectivity or something, did I? Oh, there it goes. Okay, yeah, so it's replit.com. All right, so yeah, it's storming pretty bad in Clarksville. The sky's all turned green. It's cooled off nicely though. It was very hot today and the breeze blowing in the window now feels really, really nice. So this is an online IDE. I'm already signed in here. I should sign out. Okay. I'll go back to the initial page. Hopefully not going to take too long. So here we are. The home page will kind of show some of the key points about it. Once it loads, everything goes a little slower on Zoom calls. Okay, it's probably going now. If I scroll down, yeah, you can see there some of the advantages that we see elsewhere. We work with it in the browser, so we don't have to install anything locally. Everything's installed somewhere else for us. We just access it through the browser. Multiple people can work on the same program together. That's why I really started using this. That way, when people have questions, I normally teach software development classes. If people have questions, we can just jump on here and then work on their code simultaneously. Chat rooms and all that stuff. And way down here at the bottom, there's a huge list of languages that it knows, which is not an all-inclusive list, and it's not in alphabetical order either. But there's Python, and the other assignment this week is in HTML, so it'll also do HTML. So you can just start using it, but if you're going to do a lot, you just hit the Start Coding button and do stuff. But you can set up an account. If you want to use chat rooms, and I believe without an account, you can only do 3 people at the same time, which is a lot of programmers working on the same stuff. What just happened? Reload. I'm not sure what just happened, but it didn't log me in. That's for sure. Okay, there we go. If you have an account, whole bunch of folders, all kinds of stuff. You can kind of click around, see what's there. The important button is this one up here. So all the programs you write here, they call them ripples. Whoever decided how that should be pronounced, said it should be ripple. I would have gone with repel myself, but so every program you write on here is called ripple. You just hit create new ripple and choose the programming language you want to work in. So the assignments are Python and HTML. We'll get to that in a second. I'm going to click on some other ones here first to start with. So like a C++ one. We choose C++ language and click start. It'll open up and you can see it's a hello world set up. So they already have this hello world. So we have a place to write our code, a little text editor, and then a console where we can run that code. Hit the run button and we see the words hello world print out. Yeah, it's storming pretty bad at my house. Hopefully this isn't going to last too long. Okay, yeah, that's fine. Excuse me for 1 second. The window behind my computer was open and the wind shifted and rain started hitting the computer. I was like, that's probably not good. I should close that window. If I go back and do new ripple again, so C++, so it kind of started with some languages. What's another one? Oh, Scheme. I think that has a few options. If I create a new one in Scheme, is it going to have some stuff started by default? So this is a variant of Lisp, which is a language that goes all the way back to the 50s. And they didn't start off they didn't have any code started off here. But in this, you can see there's examples. So this also has lessons on how to write in different programming languages. And you can see there's a bunch of different examples here. So this is the Fibonacci numbers. I guess the ninth Fibonacci number. That's the pattern where each number adds to the previous one. So like 1, 1, 2, 3, 5, 8, 13, 13, and each number is the sum of the previous two numbers. So apparently the ninth one is 34, or the fourth one, you can check that. So like 1, 1, 2, 3, 5, 8. Should be one of those. Run that. You can see it got up to 8. 0, 1, 2, 3, 4. I'm not sure how it's numbered there, but the point I wanted to make is there are examples of simple examples to get started in different languages if you do it this way. As far as the assignments this week, this IDE, Integrated Development Environment, knows Python. So we can do some stuff in Python once it loads. So to avoid installing anything on your computer, you can go over and do Python. Looks like there's some examples here as well. A bunch of different examples. Oh, including that one like we did the other day. Print the words "Hello World" to the console. Run that, and eventually the words pop up on the console. Let me go back to the main page. This one also knows HTML. So you saw, I just used a regular text editor and opened it on my browser. In the list of languages, when you ask to create a new RIPL, one of them will be HTML. So you can do you can practice your HTML code here. And you'll notice a bunch of that stuff that we were just talking about. The starting HTML tag and the ending HTML tag, the head section, the body section. I guess we'll have to add a paragraph in here. So I'll come down in the body and add a paragraph that says "Hello World." Same thing we just saw a moment ago. And if I click run, you'll see we get the little preview of it. So I'll come up here and do the same that style stuff. So I'll create a tag to mark out our style data. Whoops. And then things like we were talking about. So say we're going to look at paragraphs, and then in curly braces we have all of those, which is actually this file, but there's probably nothing in it. Yeah. I'll skip getting into that since we didn't talk about it earlier. I just did a style tag. I can say for the paragraphs, I'm going to change the color, make it purple. And when I go hit run again, we see purple text. So all those things we were just looking at. But the main thing I wanted to point out is both of your homework assignments, the HTML and the Python, can be handled there, and you have that little test window to try things and see what happens. But you saw a moment ago where I just used a normal text editor on my local machine and opened it up with the browser. That works as well. The assignment forum has step-by-step instructions. You'll just download that, kind of go through it step by step, and both of them can be typed up here. So that's a good place to put those together. Talk about revenue. Talk about that. Okay, yeah. So that was pretty much what I had on the list for this evening. As always, this is an active subject. We learn by doing, right? You're not going to learn much by watching me type things, right? You're going to learn a whole lot more by sitting there and typing them yourself. So, as always, I want to make sure there's plenty of lab time to go type these things. This week's assignment, there's a Python program and some HTML encoding to put together. There's step-by-step instructions on Ivy Learn. That IDE we just sort of looked at, RETLIT.com, knows both of those languages and many, many more, includes lessons and things to help you get started in the languages. So that's a great place to work on them, or use a text editor on your local machine. But that's a good thing to work through tonight during our lab time. As always, I will be sitting here until 8:50. There's a pretty bad thunderstorm moving through Clarksville right now, so my power may jump off, but Ivy Learn messages and text messages make noise on my phone, and I can get on a Zoom call from the phone as well. So if you have any questions, let me know. We can jump back on the Zoom call and address them. But otherwise, that's an hour and a half to go do stuff and actively learn, because it's an active subject. We learn by doing. Otherwise, any questions for this evening? All right, we all have a great night, and I will see you on Tuesday. Let me know if you encounter any problems while working on that. Go ahead.